Alright, so this is the video for the review on 1.1 to 1.4. Ignore the part that says honors because it's the same review for both. It's only titled that because in the Math Excel that's what the course is named, but it's really no different because y'all all see the 1.1.3, 1.1.11 and so forth. Okay, so to start with, this says determine whether the relation is a function, and how we do that is we see if this has more than one place that it's going to, but there's not, and so this is a function. So that's a yes. And then on this one it says given 19x plus 10, find f of 3. So one way to do this is to go 19 times 3 plus 10. So just on a regular calculator screen, I have 19 times 3 plus 10, and I get 67. And that's the right answer. So that's one way to do it, or you could say function 1 is 19x plus 10 and use Control T for your table. And so that would look like this. If we go to graph 19x plus 10, enter, and then Control T for your table, and then go to 3, it's 67. So either approach works. Alright, the next one says the volume of a sphere is a function of its radius, and there's your formula. Evaluate the function for the volume of a volleyball with 10.7 centimeter radius. So you're going to do 4/3 pi times 10.7 cubed. And the directions say round to the 10th, so that means 1 decimal place. And you do need to round, not just write what that decimal place is. So what I'm going to do first is I'm going to clear my scratch pad. You can click in here and then go to clear scratch pad. Then we go 4/3 times pi times 10.7 up arrow 3. And so you get 5131.448 something. And so then, since we're doing 1 decimal place, we're going to round down, so it's just going to be 5131.4. So you don't round this to 5 and then round this back up to 5 also. You ignore this part and then you round down if it's 4 or below. Alright, the next one says find the domain in the range using set notation. So remember, set notation was when you have the set of all x such that, and then you have either x less than or equal to 0, x less than or equal to something, greater than or equal to something, or a real number. Now when we graph this, I'm just going to hit this twice to get to a graph screen. I go negative 4x squared. That should be upside down. And there's no limitations for x, and so that's basically all real numbers. And so that's going to be like this. So it's all real numbers, but then for the range it's only 0 and below, and so you got to do y less than or equal to 0. Okay, and then to the next one, we have 2x plus 7 with the interval from -5 to 0. You only use that interval for the minimum and maximum. So this is only for the minimum and maximum. And so the domain of the linear function is from -infinity to infinity. And same thing for the range. Now for the x-intercept, think of it as x comma 0. So we're basically going to say y equal 2x plus 7, but really change that y to be 0. And then solve for x. So then we subtract 7 and divide by 2. So -7/2. So this would be -7/2 comma 0. Then the y-intercept is easy because remember, if it's y equal mx plus b, the 7 would be the b. So it's 0 comma 7. Okay, so now we get to the minimum value on -5 to 0. So this graph, when I press tab, then I go up arrow, I can change this. And I'm putting 2x plus 7. So it's down. That means the, wait, I kept a negative sign there on accident. There we go. So it's up because it has positive slope. The y-intercept 7. So that's the correct graph. And then you can just go to your table. And at -5, you get -3. And at 0, you get 7. Then you got to think to yourself about these, which one's smaller. This one is, and so it's the minimum. This one's bigger, so that's the maximum. And so you put -3 for that and 7 for that. So remember, if it's slanting up, the left side is going to be the minimum and the right side is going to be the maximum. But if it were slanting down, this side would be the maximum and this side would be the minimum. So it depends on your graph. Alright, our next problem is another linear function. They don't give you the equation, but we have the graph. We know this is a line, so it's a linear function. And so your domain would be the same as the other one, -infinity to infinity. They wanted interval notation, which is like, it's all reals, except for an interval notation you have to have your parentheses or brackets. In this case we have to do parentheses because anytime it's infinity we do that. Then for the x-intercept you just look at it and it's -2, and so this would be -2, 0. And then for the y-intercept you get 5. And so this is 0, 5. Then how you find the minimum on the interval from 0 to 2 is just look at what x equals 0 would look like, and it's 5 like we said, and that's the minimum. and at 2 it'd be up here, which is 10. So at 0, the minimum is 5, and so the minimum is 5. And then on 2, it's up here, which is 10. So this is 10. So just pay close attention to your interval, because we don't care about this side or that side, just between 0 and 2. Okay, so now we need to move on to the next one. A classmate graphs x cubed plus 1. He described it as similar to this, but shifted up 1. Describe any change. Okay, so let's graph the original. X up arrow 3 looks like that, and X up arrow 3 plus 1, it's just moved up 1. Okay, so there's no change to the domain, so it's still negative infinity to infinity, so you just put no change. And same thing for the range, because it still could be as wide as you want, any number at all, whether it's negative or positive. And for the range, it could be any number at all, negative or positive. The x-intercept did change, and so did the y-intercept. So how we do this is go to Control T. This is the x cubed function, and we really want the other one, so I went to the right, and we want to look to see where there's a 0. And we found it there. It's negative 1, 0. So that means the x-intercept goes from 0, 0 to negative 1, 0. And the y-intercept also changes. And even without looking at it, I know that this affects the y-intercept, and so it would be 0, 1. And you can check that in the calculator, 0, 1. So notice I'm under the red column, which is function 2. So this is negative 1, 0 and 0, 1. But if I were over here in function 1, it'd be negative 1, and 0, 0. So it's just how the calculator works. The x still shows up. Okay, so there's number 7. Number 8, we have a 9 over x comparing to 1 over x, talking about a change to the domain. So first off, the graph, (9 over x) looks like that. So if I did 1 over x just for comparison, 1 over x is closer to the axis, 9 over x is a little bit further out. So it's not anything that overlaps, so it's neither of those, and it's in this quadrant and this quadrant, so quadrants 1 and 3. So quadrants 1 and 3. This would have been 2 and 4. So that'd be if you had a negative. And then it wants to know if there was any change to the domain. it still has a vertical asymptote at 0, because remember, if you set your denominator equal to 0, that'd be where it's undefined, and so there's no change. Okay, so now number 9, you have these two functions, f of x and g of x, you're dividing them, and so you have 2x plus 3 over x squared minus 9x plus 20. So what we need to double check is if that could be factored. So when we have x squared minus 9x plus 20, using the guess and check method, we know that this would start with x and x because there's x squared. And then if you have your 20, what do you multiply together? Then what do you add together to get negative 9? So we're going to want negative 9 or negative 9x. So we can't use 1 and 20 or negative 1 and negative 20. We cannot use 2 and 10 or negative 2 and negative 10. Let's think about 4 and 5. So if we do 4 and 5, we get 9. We want negative 9. So we really want negative 4 and negative 5. Remember, when you're multiplying two negatives, you get a positive. And if this is negative and this is positive, it's a really good sign that both of these should be negative. And then you just fill in your 4 and 5. Okay, so that's what our denominator is going to be. So we have 2x plus 3 over x minus 4 times x minus 5. How this is going to help us is for this question, and notice there are some 4s and 5s in here, so I guess you can use your answer choices to kind of guide you if you needed to. But when you set your denominator equal to 0, you'd have x minus 4 is 0, so x is 4. And then it didn't matter about the right side. If it's 4, then it doesn't really matter that this is negative 1, because you'd say 4 minus 4 times 4 minus 5, and so that'd be 0. And then for the other one, if we say x minus 5 equals 0, then this part would be 5 minus 4 and 5 minus 5. And so it's 1 times 0, which is still 0. So that means you're undefined there. It's not about these type inequalities with less than's and greater thans. It's any real number except for those. And so that's going to be A. Now about this answer, since this didn't cancel, you could do this answer or you could do that answer. It doesn't matter. So either, you might want to simplify it just to help you for here, but if you keep it like this, that should work also. Okay, so now the next part, and notice this other one was on 1, 2, 15, now we're on 1, 3, 13. So now on this one we've got 8 minus x and 2 over x, and we want g minus f. So if we want g minus f, that would be 2 over x minus parentheses 8 minus x. Make sure you do the parentheses because otherwise you might have a sign mistake over here. You can either add the opposite, like change it to plus and minus and plus, or you can distribute -1, like 2 over x minus 8 plus x. And then see if you have any like terms. What they really want is to get a common denominator of x. And so for this, we're just going to keep it the same. But if you need a x for this one, it'd be like -8x over x for it to be equivalent. And then for this one, it would have to be x squared over x. So now you can order it from least to greatest and combine it. So it'd be x squared minus 8x plus 2 all over x. So that's going to be our answer. X squared minus 8x plus 2 over x. Now the next thing is we need the domain of that, and because our denominator is x, you can't have a divide by 0 situation, and so it's going to be all real numbers except for 0. So that's D. Our next one's number 11, and we have f plus g. So this one we will do 2x squared plus x minus 11 plus x minus 1. And you combine your like terms. So you drop this down to 2x squared. Then this and this are like terms. X and x make 2x. And then you do -11 minus 1, so that's -12. So you have 2x squared plus 2x minus 12. And this one, because it's quadratic, there's no restriction for your domain, and so it's all real numbers.